Hello students. So today we are going to discuss about Coulomb's law in vector form. Now those who have not seen my previous video on Coulomb's law, I request you to please check the video on Coulomb's law. So Coulomb's law basically tells us about the force of interaction between two charges. Okay, so two stationary point charges. It tells us about how the force acts between two stationary point charges. Now, since as you know, all of you know, force is a vector quantity. So of course there must be a way by which we can write Coulomb's law in a vector form. So today we are going to see how we can write that in vector form. Now as you know, by Coulomb's law we can write, so by Coulomb's law it tells us that the force of attraction or repulsion between any two charged particles is equal to 1 divided by 4 pi epsilon naught. If the medium is vacuum, then we use epsilon naught. If the medium is any other medium, then we use only epsilon naught. Okay, that is, epsilon naught is the permittivity of free space and epsilon is the permittivity of that particular medium, multiplied by q1 q2 divided by r square. So this was the formula for Coulomb's law. What is q1 and q2? q1 and q2 are the charges of both, these are the charges of both the particles, and r is the separation between the charges. Okay, now this expression we are going to write in vector form. Okay, now let us assume that these two are the charges. This is one charge, this is another charge. This is q1, this is q2. Okay, the separation between the charges, let it be r. So r is the separation between the charges. Now at this instant I am not telling you about the nature of the charges. They can be positive or negative. Okay, now if these two charges are like charges, okay, if these two charges are like charges, that means they can be either positive positive or negative negative, then they are going to repel each other with a force. So if I consider these two are like charges, then there is going to be a force of repulsion in these two directions. If these two are unlike charges, then there is going to be a force of attraction in this direction. Okay, so it can be anything, either force of attraction or force of repulsion. This force, let it be F12. Obviously force is a vector quantity, so now we have to use all the things, all the variables in vectors. So let this be vector F12 and this one be F21. Okay, so if these two are like charges, then F12 and F21, they are going to act in the opposite direction because the two charges are going to repel each other. If these two are unlike charges, then F12 will be in this direction, F21 will be in this direction. Okay, so let us first understand the variables that we are going to use. So first, this is the first important thing. We have to first understand the variables that we are going to use for this to derive. So F12, it is the force on Q1 by Q2. Okay, so F12 will be the force on Q1 which is exerted by Q2. So Q2 is trying to push F1. That's why F12 is acting in this direction. Q2 is actually pushing Q1. So that's why F12 is in this direction. F21 will be the force on Q2 by Q1. Okay, so this is F21. So F21 is the force that is acting on Q2 due to Q1. So Q1, this charge is also actually pushing, it is repelling Q2. So that's why F21 is in this direction. Okay, so these two are the forces that first you have to understand. Now since we are expressing this Coulomb's law in vector form, so apart from the forces that are acting on the two charges, we also have to consider the unit vectors and also the displacement vectors. So first let us consider two displacement vectors. So suppose I am considering one displacement vector, that is R12 vector, that is acting in this direction. That means R12 vector is acting from Q2 to Q1. Okay, I hope by seeing the diagram you can understand. R12 vector is acting from Q2 to Q1, and one more displacement vector I am considering, R21 vector, that is acting in this direction. This R21 vector is acting from Q1 to Q2. So these two are the displacement vectors. Okay, so here I am writing R12 vector is equal to displacement vector from Q1 to Q2. From Q2 to Q1. and R21 vector is equal to displacement vector from, you see, R21, it is the displacement vector which is acting from Q1 to Q2. So these two are the displacement vectors that we have considered. Fine. Now remember the directions of the displacement vectors. We are not going to change this one because this is the direction that we have taken at the start of the derivation. Apart from this, we also have to take two unit vectors. I hope all of you know what are unit vectors. Unit vectors are such vectors which give us the directions, okay, and the magnitude of unit vector is always equal to 1. So since this R12 vector we have taken in this direction, so in this direction itself we are taking one unit vector, that is R12 cap, which is acting in this direction. This is R12 cap, and this vector R21 cap, it is acting in this direction. Okay, so R12 cap is a unit vector which is acting in this direction from Q2 to Q1, and R21 cap is a unit vector which is acting in this direction. Okay, so let us write this two down. R12 cap is equal to unit vector from Q2 to Q1. This is R12 cap. Fine, and R21 cap is equal to unit vector from Q1 to Q2. So these two are the unit vectors that are pointing in the opposite direction, R12 cap and R21 cap. So these are all the list of variables that we are going to use to write Coulomb's law in vector form. So see, we have taken 6 total variables. So 6 vectors we have taken, F12, F21. These two are the forces that are acting on both the charges. It can be either attractive or repulsive. That means the forces can either act in the opposite direction or in the same direction. That means always be the. So see, over here we have taken a list of 6 vectors. So F12, F21, these two are the forces that are acting on Q1 and Q2. They can be either attractive or repulsive. Then R12 and R21, these two are the displacement vectors, okay, and R12 cap and R21 cap, these two are the unit vectors. Now from here, to derive this one, we are going to take 2 cases, but before that we are going to understand one more thing. Remember this R12, the displacement vector, the magnitude of the displacement vector R12 or R21, okay, the magnitude of the displacement vector will always be equal to R. Why it will be equal to R? You see, in the beginning only the distance between Q1 and Q2 I have taken to be as R. Fine, and since R12 and R21, these are the displacement vectors which are pointing from Q1 to Q2 and Q2 to Q1. So the displacement between them, that is Q1 and Q2, the displacement between them is R. So the magnitude, okay, the magnitude of R12 vector and R21 vector will be equals to R. Also, the magnitude of the unit vector R12 cap and R21 cap, this one will be equals to 1. We know that the magnitude of unit vector is always equal to 1. Unit vector gives us the direction and the magnitude of unit vector is always equal to 1. So R12 cap is equal to R21 cap. The magnitude of both of them are same, that is equal to 1. Also we can write R12 cap is equal to minus R21 cap. This thing also you can see from the diagram. You see R12 and R21, they are in the opposite direction. They are acting in the opposite direction we have taken in this way. So we can say R12 cap is equal to minus R21 cap. Now once you have understood all this, we can proceed to derive Coulomb's law in vector form. Now there can be, from here there can be 2 cases, you see. You see, F12 vector and F21 vector, I have given 2 directions for F12 vector and 2 directions for F21 vector. Now all of you know that 2 directions of a single force is not possible. So which is the correct direction of F12 or F21? There can be 2 cases, you see. The first case we will consider if Q1 and Q2, they are like charges. So if they are like charges, then these two forces are going to act in this direction. Okay, they are going to repel. Okay, so they are going to repel, they are going to act in this two direction. The second case that we are going to take, if these two charges are unlike charges. So if these two are unlike charges, then they are going to attract each other. Okay, they are going to come close to each other, they are going to attract each other. So these are the two cases that we are going to consider. So this one I am rubbing. So case 1. Case 1. So case 1 is Q1 and Q2 are like charges. Q1 and Q2 are like charges. So this is suppose Q1. Here we are considering Q1 at a distance of R. Here we are considering Q2. Remember, the distance between them is R. Okay. So if these two are like charges, then they are going to repel each other. So this is going to be F12. I already told you what is F12 and F21, and this is going to be F21. They are going to push each other or move apart from each other. So these two forces are acting away from each other. Okay. The two forces are acting away from each other. Now remember the unit vectors and the displacement vectors that we had taken. This one was our R12, the displacement vector that was acting from Q2 to Q1, and this one was our R21 displacement vector that was acting from Q1 to Q2. Also we had taken two unit vectors. So this was the unit vector R12 cap, this was acting in this direction, and R21 cap, this was acting in this direction. Okay. Now once you have understood up to this much, the next part is very easy. You can very easily write Coulomb's law in vector form. But one more thing, if Q1 and Q2 are like charges, that means Q1 and Q2 either will be positive or will be negative. In both the cases, remember Q1 and Q1 multiplied by Q2 will always be greater than 0. That means it will always be a positive number. Because if Q1 and Q2 are positive, then of course it will be positive Q1 and Q2. If Q1 and Q2 both are negative, okay, then of course if you multiply, it again will give you a positive number. So remember this one, Q1, Q2 will be greater than 0 in this case. Now how to write this Coulomb's law in vector form? Normally we write, by Coulomb's law we can write 1 by 4 pi epsilon naught Q1 Q2 divided by R square. This is by Coulomb's law. By Coulomb's law. So in vector form if we write, we are going to get two expressions, one for F12, another one for F21. Okay. So first let us write any one of them. F12 vector sign we are going to give. Okay. See, I have already started writing Coulomb's law in vector form. So F12, this force, the magnitude of the force first we are going to write. You know, any vector we can write the magnitude of that vector multiplied by the unit vector. Okay, that is the direction. The magnitude of the vector multiplied by the direction. Any vector can be written in that way. So this vector, the magnitude of the vector will be Q1 Q2 divided by R square. This is the magnitude of the vector. With this we have to give one direction. Now who gives the direction? The unit vector gives the direction. Now already we have taken one unit vector. Now just look at the diagram and see which is the unit vector that is acting along F12. Which is the unit vector that is acting along this direction? This one. This is the unit vector that is acting along F12. So we are going to put this one, FR12 cap. Done? So this is the expression is already written. So this one you can express, this one can be said that this one I have written Coulomb's law in vector form, because vector I have written, this is the magnitude of the vector and this is the direction of the vector. Fine. Now this one again can be written in some other way. Suppose this is equation 1. This is equation 1. Fine. So you see, from here we can write F12 vector will be equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Now see, unit vector means the vector divided by the magnitude of the vector. We can write it this way. That means R12 cap can be written as R12 vector, okay, divided by the magnitude of R12 vector. You can write in this way, no problem. Okay, because unit vector means the vector divided by the magnitude of the vector. Fine. Now before this I already told you that q1 q2 divided by r square. I already told you that the magnitude of r12, okay, the magnitude of r12 is r. Already I have written few minutes ago. The magnitude of r12 is r. So here we can put r. Fine. So the expression becomes in this way: 1 by 4 pi epsilon naught q1 q2 divided by r square into r, that is r cube, and r1 vector. So in this way it also can be written. Okay, so this one is equation 2. This one is equation 2. So this both of these equations I have written Coulomb's law in vector form. Now once we have understood how to write f12, easily you can write f21. So we can write in this way. Similarly, okay. So f21 will be equals to 1 by 4 pi epsilon naught q1 q2 divided by r square. Okay, now just see which unit vector. Of course here you have to write one unit vector. You see which unit vector is pointing in the direction of f21. This is the unit vector that is pointing in the direction of f21. Okay, this is the unit vector which is pointing in the direction of f21. So here we are going to use r21 cap. So this is your expression 3. Also it can be written in the other way. f21 vector is equal to 1 by 4 pi epsilon naught q1 q2 divided by r square. Again this unit vector can be written as r21 vector divided by the magnitude of r21 vector. Okay, the magnitude of r21 vector is r. So I can write over here q1 q2 by r square, r21 vector divided by r. This becomes 1 by 4 pi epsilon naught q1 q2 divided by r cube, r21 vector. This is equation 4. So these 4 equations you have to remember. So these 4 equations, this one is just the alternate form of this one, and once you can write f12, easily you can understand f21. Fine. So this is case 1 when both the charges are like charges. Now we are going to see if both the charges are unlike charges, then what is going to happen. There is going to be very slight change if both the charges are unlike charges. I hope all of you have written down this one. So I am writing. So case 2. So case 2 is if q1 and q2 are unlike charges. If q1 and q2 are unlike charges, then both the charges they are going to attract each other. So the forces are not going to act in this direction. The forces are going to act in this direction. This is f12 vector. This is f21 vector. Fine. Now remember, do not change these two. These two are going to remain the same, because these two we have taken at the beginning of the derivation. You have considered that r12 vector is going to act in which direction. This is up to you in which direction you are going to take. So r12 vector is acting in which direction, r21 vector is acting in which direction. Remember, the direction which you have taken for r12 vector, that same direction you have to give for r12 cap. Okay, because the unit vector obviously will act in the direction of the vector. Okay, so r12 vector and r12 cap, these two are going to be in the same direction. r21 vector and r21 cap, these two also, they are going to be in the same direction. Now it depends on you whether r12 you are taking from this side to this side or from this side to this side. Okay, so this was by Coulomb's law. Fine. Now if both of these charges are unlike charges, then of course one charge has to be positive, one charge has to be negative. There is no any other alternate way. One charge has to be positive, another charge has to be negative. Now if you multiply these two, positive into negative will give you a negative number. So remember over here, q1 multiplied by q2 will always be less than 0. Now this is very important. This one we are going to use over here. Okay, you will understand just after a few minutes why I am saying this is important. Remember over here, q1 and q2, if you multiply, one is positive, one is negative. So if you are going to multiply, so you are going to get a negative number. So that's why Q1, Q2 less than 0. Now in the same way we are going to proceed. F12 vector will be equals to, first we are going to write the magnitude. So 1 by 4 pi epsilon naught Q1, Q2 divided by R square. Now see, now we have to give one unit vector over here. Unit vector, right? Just see which is the unit vector that is acting along F12. F12 is in this direction. Okay, F12 is in this direction. See, this is F12. F12 is in this direction. So which is the unit vector that is acting along F12? This one, R21 cap. Okay, R21 cap, this is the unit vector which is acting along F12. Okay, so this is the unit vector which is acting along F12. So F12 is equal to 1 by 4 pi epsilon naught Q1, Q2 divided by R square into R21 cap. Why R21 cap? Because in the direction of F12 there is the unit vector is R21 cap. Right? Now from here we are going to use one very important formula, you can say. So now from here we are going to use one very important logic. See, over here I have written Q1, Q2 is less than 0. Q1, Q2 is less than 0. So see, first of all, this expression I can write in this way. 1 by 4 pi epsilon naught Q1, Q2 divided by R square. Now can I say that R21 cap is equal to minus R12 cap? Obviously yes. Why? Because you see R12 and R21, they are acting in the opposite direction. So R21 cap I can write it as minus R1. Right? Now just see over here what I have written. If two are unlike charges, then Q1, Q2 they have to be less than 0. Q1 and Q2 they have to be less than 0. The product of Q1, Q2 it has to be less than 0. So this is minus, this is minus. Okay. So minus minus is going to be plus. So ultimately the expression will become F12 vector will be equals to 1 by 4 pi epsilon naught Q1, Q2 divided by R square R12 cap. Okay. Why I have written? Because Q1, Q2 is also negative. Q1 into Q2 is also negative. That's why Q1, Q2 is negative. This is negative. Negative into negative will give you positive. So just see in the previous case, in case 1, when we found out F12, the expression was exactly the same. So Coulomb's law in vector form, it will not change whether two charges are like charges or two charges are unlike charges. Coulomb's law in vector form, it is going to remain the same for a particular force. When both the charges were like charges, then when we calculated F12, the expression was exactly the same. Right? Now from here we can write F12 vector is equal to 1 by 4 pi epsilon naught Q1, Q2 divided by R square. Okay, this one can be written as R12 vector divided by the magnitude of R12 vector. So 1 by 4 pi epsilon naught Q1, Q2 by R square. So R12 vector, and this one is R. So it will become just like the previous case, Q1, Q2 by R cube R12 vector. This is your F1. This is suppose equation 1, this is equation 2. This is F1. This line is very important. This line. Okay, and this is also very important over here. Now once you can write this one easily, you can write F21. So F21 vector will be equals to 1 by 4 pi epsilon naught Q1, Q2 by R square. Just see which is the unit vector that is acting along F21. Which is the unit vector that is acting along F21? This is R12 cap. R12 cap. Okay. Once again, this one can be written as 1 by 4 pi epsilon naught Q1, Q2 divided by R square. This is minus R21 cap I can write, because R12 cap is minus R21 cap. Once again, Q1, Q2 is less than 0. So this is negative, this is negative. So of course it will become positive. So 1 by 4 pi epsilon naught Q1, Q2 divided by R square R21. This is the expression, equation 3. Okay, and in the similar way, if you do, we will get one more expression. I hope all of you can do that one. That is 1 by 4 pi epsilon naught q1 q2 divided by r cube into r21 vector, in the same manner that we have done in the previous case. This one. So just see the expression for f12 and f21 in this case and also in the previous case, and just see that they are not going to change. Okay, so Coulomb's law in vector form, if we write Coulomb's law in vector form, it is not going to change if the charges are like charges, or if the charges are unlike charges, they are going to remain the same. Okay, so that was all about today's video. If you like the video, please like and subscribe.